and welcome to today's Tech Talk. It's on the trouble with chiller startups, a tale from the fields. I'm Liz Fisher, and I'm your moderator for today's session. You know, like on our webinars, we have muted all the lines so we don't get a lot of feedback noise. And I know you all are pretty familiar with the control panel, but just as a quick refresher, at the top of your control panel, you'll see a little orange button on the far left-hand side. That minimizes and maximizes that control panel so you can see your screen a little better. You'll also notice down at the bottom, you'll see a little button for questions. We ask that you enter any questions on the presentation today in that section. At the end of the presentation from Lee and Mike, we will take your questions. I want to introduce you real quick to our speakers today from the, as it's known, the Great Republic of Texas. We have Lee Ryback, the commissioning manager at McKinstry. He is the current president of the Texas chapter, and we have Mike Lackey with LCCX. He is the vice president and past president of the Texas chapter. And with that, I'm turning it over to Lee to get started.
Well, thank you, Liz, and appreciate everyone being on with us today. So I'll say good morning or good afternoon, depending on where you're located. Mike and I will be presenting today on the trouble with chiller startups, our tales from the field. This actually all started last fall when we were at the leadership conference, and they asked each of the chapters to put together a tech talk for this series for members only. And at the time, both of us were on projects where we actually were having issues with chiller startups. And we thought, well, we're both right in the middle of it, so maybe this would be an area where the two of us could present on the topic and talk a little bit about our various and sundry project issues and challenges. So today we're going to talk about the chiller startup process. We're going to go back to basics and talk about all the parts and pieces, and they're often problematic, and part of the reason is because they're relatively complex systems of their own. So they're often stumbling blocks for the construction team. So one of the things we want to do is talk about how we as commissioning providers can help them potentially avoid those. And we'll talk a little bit about our tales of woe from the field and what we did about them, and what should we do as commissioning providers when things inevitably go wrong. And as Liz mentioned, we'll have a Q&A section at the end. So early on in your commissioning provider involvement, hopefully in pre-design, you'll be talking about equipment selections, installation challenges. If you're holding design charrettes, you're talking about alternative concepts and various ways of providing the services to the facility or groups of facilities if it's a campus. So there'll be system selections, there'll be submittal reviews, and as they start to install equipment and systems in the field, you'll have your installation verification. So hopefully, if you're getting involved early as a commissioning provider, you're going to be very familiar with the systems, the type of systems, how the design team got to the place of selecting the systems that are being installed, so you'll have the whys and wherefores about them, and hopefully have had some input in order to make sure the systems are accessible and reasonably interoperable, meaning that they'll all play nice together once they get in the field. So we want to talk about understanding the systems, and this is especially important if, wow, out of the blue, you're sent to the field and hadn't been part of this earlier design and selection process. So I'm going to turn it over to the professor now. Mike, if you will.
Well, thank you, Dr. Ryback. I appreciate the handoff and the accolade. Good morning, everybody, or good afternoon, I should say. As Lee said, if you are sent the last minute cold into the field, it's going to be pretty problematic if you haven't had a chance to study the system and understand the operation of the system. Obviously there's a chilled water system, but you may have a DX chiller, or you may have centrifugal chillers that are going to require a condenser water system. Your the condenser water may go to cooling towers. It may go to a pond. There's no telling. And then there's pumping schemes that are involved, whether you have static and variable primary and or variable primary, variable secondary, variable and or static tertiary with the bypass. So any number of these systems. We've got a couple of slides here to show you. Lee, chilled water with a primary, secondary. The primary pumps are direct drive. The secondary pumps are VFDs. Next slide. Here's a primary, secondary with a condenser water system. We've got 3 sets of pumps. This particular illustration doesn't show whether you've got variable or direct drive pumps, but obviously you've got a cooling, or you've got a condenser water loop going to your cooling towers. You may or may not have a storage tank. Your primary chill water pumps are I like to say pulling the water and pushing it through the evaporator side, and then your secondary chill water pumps are helping push it through the cooling coils. So anyway, it's quite important to have to be prepared when you go into the field to do this. And as I like to say, you've almost got to have thought through and worked through the whole commissioning process. What happens if you're successful? What happens when you're not? Again, we talk a minute here about compressors, centrifugal compressors, a great majority of what we see, but they've got an operational sweet spot that is good for energy efficiency. If you get too low on load, you're going to start surging. And I got to just tell a quick story about the first time I ever heard a centrifugal pressure surge. I thought the world was coming to an end. And I just imagined all kinds of vanes and parts fly in my direction. Anyway, I've since come to find out it's quite not as terrible as it was. But anyway, still, it'll get your attention. Again, speaking about the operational sweet spot, it's probably loaded up somewhere like 75% load is a good sweet spot. So you're going to have your strategy as to how you add or subtract chillers. Scroll compressor, air-cooled chillers, typical in DX units. A lot of smaller jobs only have DX equipment, or at least here in Texas anyway. They're good for low turn down. So you can see from the carrier picture next door, it's got 4 stages of compressors. So those are usually controlled internally to add load or subtract load, as the case may be. They're very efficient over a wide range. Screw compressors are again durable and have a good operational sweet spot as well. Anyway, let's move on. Thank you.
Yeah, talk a little about chiller prerequisites. So I know we've gone over kind of the design side of the system, so they've been installed now. Obviously, they better put in some piping, and they better put some water in it. And if they did the piping before they put the water in it, they should have hydrostatic tests, which should be signed off by the authority having jurisdiction. And they better have flushed those lines and pacified them. They better have all their power disconnects and variable speed drives powered up, hooked up, programmed. Controls better be operating, including the isolation valves. They better have their pumps, and whether they're variable or fixed speed, they better be started up. The drives better be set up. Things really need to be, ready to go, especially if they've got you called out as a commissioning provider to begin the startup process and watch them, getting into it and witnessing it. So all of these systems come with valves. Some of them are isolation valves. Some of them are bypass valves. Speaking about the plant, of course, out in the systems, you'll have your control valves at your coils, as Mike mentioned earlier about getting the secondary pumping out to the chilled water coils and the air handlers, or fan coils, or whatever other equipment, computer room units that might be out there. So in the plant, you're going to have isolation valves. You may have bypass valves. You may have bypass valves for condenser water. You may have bypass valves for chilled water. A, are these hooked up? B, are they under control? And as you can see from the three-way valve with the linkage, has the linkage been confirmed to be in the correct orientation? I know it seems simple, but I know Mike and I can both tell you about times when those things were not properly attended to. So speaking of surging, Mike, that's one way to get it, I'll tell you. I guess those valves not set up correctly. So back to our pumps, we might have our static pumps. We might have a bypass either in the plant or out in the chilled water loop in the building. Typically today we see secondary pumps are primarily variable. We also see primary variable systems, so there's no extra set of pumps. There's just the primary pumps under variable control. So the variable speed drives, which are also known as variable frequency drives, and they get their name by controlling the frequency and chopping it up and reforming it in order to take the power, put it into a DC bus, and then put it back out as AC power. We won't talk about that today, but needless to say, it's a complicated subsystem of its own. So you need to be sure those things have in fact been properly set up and that their parameters have been ranged correctly with the controls contractor. So one thing I would like to recommend to you as a commissioning provider is to try to be on site with the VFD startup and a controls technician at the same time to make sure they get their parameters ranged correctly. And just about the only way you can guarantee that the startup person for the drives and the controls tech will be on site at the same time is if you insist on being there to witness it as the commissioning provider. So that's something I'd like to recommend to you as a way to make sure that your startups go a little better. So as we move on to the cooling towers, we've got different types of towers. Again, if you weren't involved in the submittal review process, you've got your flooded tray towers, spray array towers. They do operate a bit differently. They may have isolation valves. They may have bypass control, either in the chilled water or the chiller room, or they may be out by the tower itself. The fans should have variable speed drives. Typically today we see them with sweeper systems. Well, those sweeper systems are, again, subsystems. They've got control panels. Have they been started up? Have the controls been configured? Has somebody checked it out thoroughly, like the startup tech for this sweeper system provider? And any of the problems with the things I've just mentioned can bring on issues with the chiller, with head pressure control, with chiller staging, both staging up and staging down. And they can cause a lot of headaches, especially if you have a variable condenser water pumping control scheme in place for the project. So although these are various and sundry systems and they're generally out with the tower outside, either on the roof or on the ground, they are just as much a part of your chiller room as the chillers are. So recommend that you pay real good attention to them as well. So Mike, what can we do to help on these startups?
Well, I think it's critical in our role as commissioning providers to kind of shepherd the whole process along. I really see a commissioning provider as a person who organizes all the different parts and pieces. In our industry nowadays, everybody's got their specialized function. You've got the controls contractor, you've got the mechanical contractor, you've got the equipment suppliers, you got the startup engineers for the equipment suppliers. So everybody's got a little job, and ours is the key role is to make sure that all the parts and pieces fit together. Uh, Commissioning provider witness. As Lee said, nobody's going to do this unless they know that they've got a test coming, and they've got to prepare for the test. So our role is critical in uh, leading the process. Everybody in our industry wants to do a good job, tries to do a good job, but we all have constraints, and with our time, our talents, our resources. So I truly believe everyone wants to do a good job. They just need a little help in finishing the whole job. So startup reports, it's critical. You've got to stay on top of them in terms of basically urging and requesting startup reports. It just doesn't, very rarely, I suppose, do I get the startup reports handed to me before I have to ask 2 or 3 times for them. So, again, leading the process, setting deadlines, articulating a plan is all very critical. Got a load. What should the construction teams do about it? It's pretty hard to start a chiller plant unless you've got some sort of a load. And that means typically having the building in some kind of a drying out process, trying to reduce the humidity inside so they can start doing some of their finishes. So again, very critical to get the construction team involved, make sure that they're ready to put load on. Or in some cases, you may be connecting to an existing plant, and there may be sufficient load in an existing building. So the next one, devices are installed, but do they work? Well, we have a whole set of stories about perfectly installed equipment that is either not hooked up, not calibrated, or not ready. Anyway, as we move along here, talk about the control sequencing. Very critical. The add, subtract control strategy, staging the chillers, getting the appropriate loading on the chillers, restart timeouts. Should we have a piece of equipment drop offline? How long is it going to be before it can get back online again? Especially if we've got a load and we're trying to walk up and down the sequence of loading and unloading. Safety routines, always key. We've got to keep in mind safety.
Hey, Mike, could I chime in right here?
Go right ahead.
Well, thank you, sir. I was on a project early in my commissioning career, and the sequence for the chillers was written right around the safety routines that were already built into the chillers. So we had the building automation system trying to do the same thing the chillers were trying to do. And I have to tell you, that led to some unusual and unique problems. So valves were closing and sequencing from the chiller and from the building automation system, and at exactly the same time sequence for the timeouts and the safety routines in the chiller, because that's how the sequence was written. And you talked about the chiller surging, and you were concerned it might come flying apart. Well, I got to watch the 10-inch chilled water and condenser water lines dancing around on their restraints and sling supports in the chiller room while we were standing there. So that was pretty exciting.
Pretty exciting. That's one of our first tales from the field. So we've got several more of those to show you. I believe I'm finished with this. Let's go on to controls, Lee.
Very good. Didn't mean to cut you off there, Mike, but that story about the chiller surging reminded me of that one with the pipes dancing around in the plant. That was kind of exciting.
Excellent example.
Well, thank you, sir. So on controls here, we got to look at things like recognition of failed equipment. Do we have proof of flow? Do we have proper failure rotations? We have temperature readings, we have alarms, we have statuses and mismatches. Are all of these things showing up as alarms in the graphics for the building automation system? I know that all of us get involved with things with graphic user interfaces not being really complete at the time we're doing startups because it's quote unquote so early and the systems aren't all ready and they really need the chilled water. Mike was mentioning about getting the building conditioned enough that they can start doing finish work on the interiors. So here you are trying to start a chilled water plant. You don't have a complete set of graphics. Are you getting your notifications? All the things we talked about earlier with the devices and the equipment, and is it programmed and are the parameters set up? Well, here you've got a series of things you're trying to review at startup, and maybe they're not 100% complete. So then we get to our sensors. Are they calibrated? Are they connected? In fact, at the time that Mike and I were talking about putting this little project together to provide this presentation to you, I was on a project where we had just been told that, hey, the plant's ready to go, the DPs are in, they're installed, and we can get in and get those chillers going. Well, I went to the plant, sure enough, after the meeting. This is very exciting news, and there were the differential pressure transmitters on the wall, and yes, they were installed. Now, they weren't piped, and they weren't wired, but they were installed. They're ready to go. So all of these things, have they really been checked out? Are they working? If you've got flow meters, do they have factory certifications? They certainly should come with them. And like Mike talked about earlier, if you don't ask for them, you won't get them. And then all your temperature sensors in and around the plant. Are they field calibrated? Are they functioning correctly? Is there connectivity between the variable frequency drives or the chiller and the building automation system? And did the building automation system contractor, provide you with these point-to-point checkout sheets? I know we all ask for them. And the controls guys, being the clever fellows that they are, have learned to take what are called commissioning reports right out of the field controllers, which is really nothing more than a point report from the controller. But it's not an actual checkout sheet. That's something you can look for in the field and make sure that they provide you with the real deal. So, Mike, you want to talk a little bit about hydronic systems now that we got things more or less working the right way?
Sure. This is just a list of things that I've encountered in the past, and I'm sure if I could see you all, you'd probably be nodding your heads as we go through these. Flow indicators installed in the wrong locations. Indicators installed with not enough straight pipe diameters upstream or downstream. How many times have we had to, have them relocated because there just wasn't enough laminar flow? Flow indicators incorrectly sliced. Flow indicators with wrong orifices. It came from the factory. It had to be right. Did you check? Sometimes it behooves somebody to check the submittal against the shipping ticket, and sometimes that ends up being us. Autoflow valves, spring operated, or the cartridges not working or stuck or incorrectly outfitted at the factory. Going through a case like that right now. We've got 2 brand new autoflow valves, and that's been installed twice, and surprisingly, both of them are not working. So we're trying to get to the bottom of that. Air handling unit coil knockouts not removed. Packing cases, whatnot. Let's go on to number 7. Coils hooked up backwards. I mean, how many times have we seen that? Temperature control valves installed backwards, either 2-way or 3-way configuration is wrong. Dirty systems with clogged coils, strainers, Hopefully they've got strainers in line and have dumped the strainers a couple of times before we get there, but it's not always the case.
Say, Mike, I was wondering, have you ever found like unusual materials in the pump strainers.
Oh, you mean like number 11? T-shirts, bottles, rags, well, I never have found a hard hat yet, but I've always heard of that. But
How about a Coke can?
Coke can, I hadn't run across a Coke can. Lots of welding rods, however.
Oh, yeah. Well, you know what's great about Coke cans? They compress in the strainer basket, and then they start gathering other debris around them.
Sure.
Yeah.
Yeah, and it won't blow down when you try to blow down the strainer either. So somebody's got to take it apart and find out what's in there. Finally, systems pipe backwards. You think everybody know that which way the arrow is supposed to go, but maybe we get in a rush when we're out there sometimes. So always good to follow the arrows and make sure they go the right direction.
Well, that's a good point. I was on a project once where there were two portions of the building, and of course, with the sequencing of construction, one side was finished a little bit ahead of the other. So the lag system, when they went to finish the piping, underground piping up into the building, they swapped the hot water line supply and return. So guess what that did to all of the piping for the hot water coils in that part of the building? Kind of goofed them up, didn't it? In other words, we had hot water flowing the wrong way through all the valves. Boy, was that a problem. Holy mackerel.
Hopefully everything downstream was installed correctly, so that meant it was going backwards through every device.
That is correct. Backwards through every device. And you were talking about those auto flows. Well, guess what happened to the auto flows on the hot water coils and the air handlers? Gosh, I'll bet they didn't work very well after that, huh?
That's the kind of situation where maybe they need to be, even the devices and indicators, when you get a situation like that, maybe they all need to be removed and inspected to make sure they haven't been damaged by taking flow against the in a direction they weren't meant to take the flow in. So
exactly. So this gets us to our even when it's correct, it can be wrong. So here the auto flows in that building were all correct, but they were damaged and ruined by having the piping incorrectly assigned the supply and return from the underground into the building. So here, this is a central plant that I worked on, and we had flow meters from the central plant for each building. Everything was great. We'd verified meters, done all our checkout. But look at this one. You cannot imagine the look of shock on my face when I saw this meter, sometime later after we'd gone through and verified them. We had factory certificates on everything and whatnot. And then we did field checkout. So I thought I was being really responsible. And here I thought this thing had just failed completely. But it turned out that because this flow meter went out to a building, somebody in the building, for whatever reason, had opened a bypass line close to where the piping came into the building. So the truth of the matter is this meter was working correctly. Unfortunately, it was running backwards. It was a magnetic meter rather than a turbine, so it didn't ruin it. And eventually they got that valve put back in the correct position, and this went back to reading in a positive direction. So even though we had done everything we could do, all it took was one building operator, and boom, the thing was running backwards. So here's an example of a project I was on. Everything was installed. It was very high quality, industrial grade flow meter, an industrial actuator to manage the chill water flow. I mean, you couldn't have asked for better equipment. But the problem is that the devices, both of them, the actuator and the flow meter, were not properly scaled for the building automation system. So we had these great parts and pieces, very expensive equipment, and they were not really talking properly to the building automation system. Well, since those guys weren't working right, our chilled water plant, which is our planta de enfriamiento, was not working very well either, because the chill water flow was not correct, reading from the meter to the building automation system to the valve, and so our control was completely hosed up. Now, once we got those things scaled correctly, then everything went back to working in a very normal way. So it was a success in the end, but very frustrating in between. So, Mike, do you ever have contractor issues?
Well, that's it's kind of a loaded question, and I do hope we have some contractors that are on the webinar with us today. I run into a lot of really good contractors that, as part of their QA system, may actually have some CXs on their staff. So anyway, I guess we get to the first thing. What's your definition of ready? We've all heard about, yeah, come on out, we're ready for you. We got to have you Monday morning. And you get there, they're still running control wiring. That's pretty typical, I would say. They say, we're ready for you. And I say, have you had your factory startup sheets yet? And they say, no, we were waiting for you to start it up. Well, what I insist on with our customers is that we've got the factory startup sheets, we've got the pre-functional checklists completed, and we have a tab report to say that I'm ready. Now, obviously, we get out there, we do what we have to do, and we make the best of whatever situation we have. But anyway, it is hard to commission a system if you don't have everything hitting on all 8 cylinders. Control's not fully ready. You may not have a point-to-point. They may still be working on the programming, figuring that they're going to finish it up that afternoon. If you start the commissioning in the morning, they're going to keep programming, and they'll have it ready by 5 o'clock for you. So, probably with a few bugs. Anyway. Graphics still under development. So many times, we're looking at the screen on the controls vendor's laptop, saying, "Well, this is what you would see if we had the graphics ready." And graphics are kind of a big deal with me because it's going to be the end user who has to deal with the graphics. And, if they're not to his satisfaction, if he doesn't understand them, then it's going to be problematic for him. He's going to have a bad experience operating the building. And finally, matching the approved submittal with what's in the field. That's one thing I focus on is the controls contractor. I try to have frequent meetings with them in the field, formal meetings, usually as part of a job construction meeting. We try to meet with them afterward just to make sure of their progress and to verify that their progress is such as they say it is.
Say, Mike, I wondered if I might interject here, looking at the image of the chiller and all of its data points. And speaking of the graphics and not being ready, I was on a project once where the graphics were ready and the chiller had been started up and was able to run, but the interface between the chiller and the building automation system was simply not working. And of course, the chiller guys said it was the controls guy's problem, and the controls guys kept saying it was the chiller guy's problem. And this went on for a long time, and we finally prevailed on the local chiller service manager to try to get us somebody out to the job site who was very familiar with the intimate details of the chiller's digital control system. And it turned out that the COM board for the interface was in fact installed with the control panel from the factory, just like it was supposed to be. But there was a what's the word I'm looking for? Like a firmware switch to turn it on, to tell it to go talk, and that had never been turned on. So we finally got a guy out there, he plugged into it, and he said, oh, well, it's not on. So, of course, he turned it on, through software. I kid you not, by the time we got to the operator's office, that screen was totally populated with this information. It's just amazing. It's like, you can't make this stuff up.
Well, I like to say as commissioning agents that we are skeptics. We don't believe anything unless we can see it. And the thing that gets us in trouble, or maybe gets everybody on the project in trouble, and keep in mind it's not a us versus them. It's a team. We're the leaders. We need to motivate and cajole and bribe and browbeat as we need to move the whole process along. It is a team process, but most problems get resolved because I assumed something was ready, or I assumed the switch was in the on position. So making assumptions, you can't make assumptions. You need to take everything prove it with your own eyes. Anyway, as we move forward here about troubleshooting, we talked about surging earlier. That's always a scary time. I'm always worried about damaging the equipment, or worse yet, getting somebody hurt by piping that flies loose or something like that. Low flow shutdowns. If we're not getting enough water to prove flow, then that's a chance that the chiller's will go down. Low suction shutdowns. If we're not getting adequate suction flow, then we'll have a problem. Low delta T across the condenser, low delta T across the chiller. If those last four items, if those are all working, then you're probably going to have a pretty successful chiller startup.
Well, that's true, and I wanted to just point out some of the things that we had talked about earlier about valves and valve positioning and linkages and variable frequency drives being properly scaled to control systems, the building automation controllers. All of these things can lead to some of the problems that are listed here. So as the commissioning providers, and Mike alluded to it a little bit ago here, have we done everything we can do as a commissioning providers? Have we led a team building effort? Mike was right. This isn't an us versus them thing. As commissioning providers, we can't verify anything that the contractors and all of the folks involved in the project haven't shepherded to completion. So one of the things I really try to make an effort to do is make recommendations kind of over the horizon. A lot of times you're in meetings at the construction site, they're talking about this week and next week, and I try to talk a little bit about down the road, some of the things that Mike and I have been covering here, that you can see coming up. How about you, Mike? Do you try to do some of those same things?
Yeah, we try to. Everybody's running in the field. Everybody's got a priority that they're trying to meet. It's not always our priority. It's more about meeting a milestone or being able to check off something's completed. And everybody's looking at their own little territory and trying to get their job done. So, I always try to get the general contractor to take commissioning seriously, and get his subcontractors to take commissioning seriously. The best kind of advice I can offer them is, look, if we do this right now, we won't have a bunch of service calls and we'll keep our client happy. So, kind of focus on some of the positive outcomes. It's not just about checking off the box that piece of the chiller installed and walking away from it. There's a lot more that goes into it than that.
Yeah, and things are inevitably going to go wrong. I mean, we've, tried to cover in a brief overview um, some of the things that are involved with a chilled water system. And of course, a chilled water system is the heart of any HVAC system in a building or in a complex. Well, things are going to go wrong. So one thing I like to recommend to folks is commissioning providers, hey, don't rub it in. It's going to happen. Get used to it. What can we do to help? How can we help them recover? And I really try to make a point of thanking everybody for their help and their contributions, not only on the day that things went wrong and we recovered, but as we go along the way. Thanks for having that ready for us. Really appreciate you getting us those factory certifications ahead of time, and try to kind of keep it on the upside. Try to stay positive. Anything you want to add on that, Mike?
No, you're absolutely right. Pointing was there some saying about let's fix the problem and not fix the blame. It's easy.
That's a good one. I like that.
I saw it in a movie, a Sean Connery movie, many years ago about the. Anyway, I won't digress, but let's focus at the end goal, which is having a smooth running system for our client, all of our client, who's the end user. And, let's, this is construction. Stuff happens. So it's not a surprise. It's inevitable. And we just got to help. We all got to get through together as a team. And I really try to approach it as a team approach. It's not me against the world. It's not me against you. It's the you being any supplier or contractor, but we're all in it together. So when the team wins, we all win.
Absolutely. And really, in the end, our job is to help the construction team deliver a functioning, usable facility to the owner. So that's what we're here for, and chiller startups are just a part of the process. So Mike and I would like to thank everybody for your attention and attendance, and our Tech Talk today, the trouble with chiller startups and our tales from the field. And we'll be happy to take any questions. So Sherry, Liz, you guys have anything for us?
Yeah, we got a couple of questions here for you. What is a good average time for passivation in a large system with a centrifugal chiller and cooling tower, or is there an idea time?
Can you repeat that? An ideal what description?
An idea time. So is there an average time
for pacification?
Yeah, in a large system with a centrifugal chiller and cooling tower.
Well, ideally, it all runs and is balanced as soon as you flip the switch, but that's not the case.
I'm sorry, Mike. That made me laugh. That was a good one.
Well, that's ideal, but
yeah. Anyway. Well, I think in answer to the person's question in technical terms, it depends a lot on the system. I mean, and I don't know about, maybe Mike would like to add something to this, but it seems like there's so much staging in construction that they're never able to do the whole chilled water system at once or the entire condenser water system at once. Do you find that too, Mike?
Yeah. Our life has gotten much more complicated. It's not a step A connects to step B. It's a bunch of other steps in the process. And what as I understand the question, a pacification means when is everything lined up and running properly? And that's really a hard question. That's why I answered it in that flippant manner. I apologize.
Well, I'll take a shot at it, Mike. If you're talking just about the flushing and passivation of the pipe and it's a reasonable size system, it's going to take several days. Is that fair?
Sure.
Okay. All right, Liz, anything else for us?
You mentioned requiring a tab report before commissioning startup can commence. How much hydronic tab can really be done before a chiller startup?
That's a trick question, isn't it?
Yeah, you sort of got me there. But, there's startup of the system, and then there's the official commencement of the commissioning process. Ideally, the startup techs ought to take place. The equipment ought to be started up, and the systems started in some kind of flow before we do what I'd consider the formal commissioning process. Lee, you got some thoughts on that?
Yeah, I agree. There was a good trick question. Obviously, there can't be test and balance before we're doing the raw chiller startup, or at least very seldom. But we should always have test and balance, including hydronics, before we get into the functional testing portion of our work. Is that a fair way to put it, Mike?
I think so.
Okay, a couple more. There's an increase in chiller optimization software in the market. Any advice or lessons learned on setting up automated chiller sequencing software?
Well, that is a good question.
Automated. Did you catch that? It's automated. They don't need us. See, Mike, they don't need us. It's automated.
Well, that's all well and good. I'm not too worried. I'm not too scared. Yeah.
Well, I think they're referring to some of these pre-packaged programs that some of the chiller manufacturers have. Some of the skid chill water plant guys are using like the Hartman loop, and I think some of the big controls companies like Johnson and Siemens have their kind of pre-packaged chiller optimization. That's kind of how I took the question? Is that how you hear it?
Yeah, that's what I think our listener is asking. I don't really have a good answer for that. These optimization programs are being sold early on to the owner typically, and he's wanting that to be installed, if you will, and it is hard sometimes if to really get a baseline running, and I'd urge them to add that at a later point. Let's just make sure the system's running properly before we start customizing it.
Well, I would like to tag on to that. I think if the systems are coming with these pre-packaged optimization routines, I agree with Mike. Best to have the building automation vendor not engage those until we've gotten through the system startup and we've gotten through the functional testing to show that everything is working correctly. I have had some experience with pre-canned optimization programs creating problems when they're engaged right out of the box, as soon as the controls or the plant get up and running. And I have run into some problems with that. And basically the way we fixed it was just, well, turn those off for now and let us get through the rest of the startup and commissioning process.
Okay. Any thoughts on how to go about testing alarm systems such as low suction and low delta T?
Ooh, that's a good one. Well, how to test those? Well, I guess you could slow the pumps down on the condenser water and the chilled water, or force the bypass valve of the one direction or the other, and see if you could cause the alarm to happen. I don't know why we would want to do that. Is there any clarification, Liz, on the question?
No.
Okay, well, it can be done. I don't know that I would want to spend much time and effort trying to cause a chiller to fail. Will have been my experience, Mike. I don't know about you, but we've had plenty of opportunity for that.
Yeah, I that's my thought too. Is that we're gonna be able to verify that the chiller shuts down on low flow, just because it will as we're starting up the plant and trying to get it running.
Mm-hmm.
Can you speak more to the tactics to drive better coordination between installing contractors, especially when electrical may be providing the VFDs and mechanical providing hydronics, and getting things all aligned before setup?
Well, the only thing that I could respond is you almost have to have hold additional coordination meetings for those activities. Mike, how about you?
Uh, yeah, there's no easy way. There's no trick other than just getting everybody sitting down together to visit for a few minutes before we're too far along.
Yeah, I would say the earlier on, the better.
Yeah, absolutely.
And just a little visit, huh, Mike?
Little visit.
Little visit. Last question for you. Can you talk more about the increase in using PICV, new term for me, in chilled water applications to address low delta T?
I'm not registering. You got anything on that, Lee?
Did you say TITD?
No, P is in Paul,
Oh,
ICV.
Okay.
And chilled water applications to address low delta T.
Okay.
Pressure versus volume or flow or something.
What it sounds like,
I'm
yeah.
familiar with it.
Pressure independent control valves.
Oh, pressure independent control valves in the system and what their effect is on improving low delta T operation. I presume
And
that's the question.
Yeah, and chilled water applications to address low delta T. Yeah.
Okay, well, they can be a good application. And again, if it really comes down to proper control. Are the controls set up correctly? Are they operating properly? Are they reading temperatures and pressures and flows correctly in order for those valve manipulations in the field to try to help offset potential problems in the plant? Mike, you have any thoughts on that?
No, I'm good. I'm glad you covered that.
All right. Well, I want to thank you both. You did an excellent job, and thank everyone for joining us today. We will get this up on to the website as a recorded Tech Talk as soon as possible, and wish you all a happy and productive work week, and we'll talk to you soon. Thanks, everyone.
Thank you.
Thank you. Bye now.